Welcome back. Today I'm going to be going over this quadratic question that usually comes up on the SAT. Um, if you haven't watched my other SAT videos, I recommend you do so. There's a lot of useful tricks I do cover, but in this one I do want to show you a specific trait that shows up, and it's actually really useful to know. But I don't want to waste any more of your time, so let's get right into it. So first, try this question for yourself. Okay, assuming you're given a try. So we have p of x, which is a quadratic function, and it passes through these given points here. We are asked to find the value of p of 19, right? So there's actually two ways you can approach this problem. The first way utilizes Desmos, right? So what we can do, if you look at on the right, is make a table, type in the points they give you. So we have 1 comma 15, 7, 123, and then of course 13 to 91. And what you can do with these points now, essentially, is click that regression button, right? Uh, and then you can click on quadratic regression, right? Because again, this is a quadratic function, right? So a quadratic regression essentially gives you the approximate graph that would go through all these points, right? So now we can actually use this graph to find the value at 19, right? So since we're trying to find the value of the function p of x at 19, you would put x equals 19 here, right? And then you would see where that intersects with the quadratic function, right? And as you can see here, right, it intersects at the value 519. So that tells us that p of 19 equals 519, and therefore our answer choice would be C. Now, I also want to show you another way, right? Because using regression is always not reliable because sometimes Desmos actually messes up your regression graph, right? So another way to think about this problem is actually mathematically, right? What I mean by that, well, here, you notice that the points they give you, right? You have x equals 1, x equals 7, x equals 13, and x equals 19, right? Those x like coordinates, right? They're all spaced by 6, right? There's a difference of 6 between each of the given points they give you, right? Even from 13 to 9, right? That's a difference of 6. Why is that useful to know? Well, because there's a really special property about quadratic functions that you should know, right? If I had, so again, right, we have x equals 1, which gives us 15, x equals 7, which gives us 123, right? We have x equals 13, which gives us 291, and again, we're trying to find x equals 19. So I written it like this for a specific reason. Let's calculate something first, right? So from 15 to 123, right? What's the jump between those two values? We'll calculate that, right? So 123 minus 15, that gives you 108. And let's do the same for the next two numbers. So 291 minus 123, that gives you 168, right? And we're trying to find this. Well, what you'll notice is, well, we don't know what this number is, right? We don't know how much this number, what the jump between this and that possible value at 19 is. But there's actually a way to figure that out. Anytime you have x coordinates that are spaced out evenly, right? This is a difference of 6, 6, 6, right? Right? What you can actually do is look at the second level of the difference, right? So you can think of this as the first level, and then your second level, right, is your difference between your differences. So that's second level, right? And An important thing to know about quadratics is that your second level difference actually is constant. So let's calculate that. So here, the second level difference is 60, right? And again, right? Again, very important thing to know is that your second level difference for quadratics is always constant, which means the jump from 168 to whatever this might be, that's 62, right? That's 60 also, right? So, well, now we can actually find the value, right? Because let's calculate, right? What's 168 plus 60? That's 228, right? So we're given this value of 228 here as our difference, right? As our first level difference. Now, we can actually find the value, right? Because now we know that's 228, and that jumps from 291. So we can do 228 plus 291. So again, I'm just going to add 291 to this, and you get 519, right? So, and then, yeah, we will, of course, pick answer choice C, which we also got earlier with our Desmos method. But I do think if you recognize that you have 3 points that are spaced out evenly for a quadratic, um, this is a much reliable way of finding your answer choice, because regression equations actually are sometimes inaccurate when you calculate them on Desmos, right? So there we go, right? Key thing to realize again is you have a first level difference, right? Which are these numbers, and then you have a second level difference, which is like your uh, the difference between your differences, right? And your second level difference for quadratics are always the same, right? And if it's a cubic expression, good thing to know is like your third level difference is always the same, right? So again, I think this is a really useful trick uh, for this specific problem, right? But hopefully that made sense. If you have any questions, of course, leave it down in the comments, and I'll see you next time.